Hey kids, it's Matt here. Got a little different background for you today to share. Got to talk solubility and solubility curves, and these involve a graph. So I kind of wanted to have a little bit of grid paper. So a little bit of eye. Wake up! We got some yellow going on. So first, let's talk about a nice definition here of what is solubility. What we've done is had a series of videos on solutions and making them. And now we're going to quantify that a little bit by saying that solubility is the amount of solute. And we're going to measure that in this case very simply. The solute in grams in a given amount of solvent. And in this case, that's going to be per 100 mils. And so if we look at solubility, that's going to be measured in grams solute per 100 grams of water, or in this case, grams solute per 100 mils of water. We're going to use those two interchangeably because, let's face it, it's water. Its density is 1. So grams per 100 grams is what we're looking at here. And so we can graph these. As a matter of fact, if we were in school, we would make, one of the labs is to make a solubility curve. And that solubility curve is going to have solubility over here in grams per 100 grams. And what do you think? Solubility is probably going to be measured in terms of temperature. If we heat something up, it becomes more soluble usually. And so we're going to put temperature over here on the X. And now we're back to our old friend Celsius. We're no longer in Kelvin. Remember, Kelvin is just for gases. Now we're in Celsius. And most solubility curves are going to be upward, and they may have a curve to them. They could take a lot of different forms. And that would be okay. There are 3 areas of this, though, we do want to make note of. We have this area underneath, which is unsaturated. That unsaturated means you could dissolve more. More could go into solution if needed. Okay? And on top of the curve is an area that we call supersaturated. And that is maxed out. It can't dissolve any one more bit. And so often, if you order iced tea in a restaurant and they bring you that and you take some sugar and you put the little sugar packets in and you stir it up, some of that sugar is going to dissolve and then some of it's going to settle on down. Well, how do you make sweet tea? Sweet tea, y'all know this. What do? We're going to take that sweet tea, we're going to heat it up, make hot tea, put the sugar in, get a lot of it to dissolve, and then as it cools down, it's going to hold that sugar in solution. You're going to have a supersaturated solution there. And that's how we do that. We heat it up. Now, on the line itself, okay, my line then is the difference between, and this is kind of hard to see. I'm going to go back to my blue. This is saturated. That is holding the max amount of solute. What's the difference between supersaturated and saturated? Saturated is going to be, it's holding the maximum amount. Supersaturated, it's unstable. You've maxed it and it still has more in. So that cold glass of tea that we added the sugar packets to, what happened? Some of those sugar molecules, those sugar crystals, they're sitting on the bottom of the glass. They're not quite there yet. They haven't dissolved. So these are three terms that we use to describe a solution. And in the solubility curve worksheet that you guys are going to have, there are going to be numbers that go along with this. And we're just reading our graph. And so I want to remake this solubility graph and answer a couple of sample questions. And so this time, I'm going to make my graph look like that. And we're going to have solubility over here, and we're going to have temperature over here, degrees Celsius, grams per 100 grams. And we're just going to go 10, 20, 30, 40, whoops, ignore him, 50, 60, 70, 80, 90, 40, 30, 20, 10. And we're going to get temperature over here. And we're going to say 10, 20, 30, 40, 50, 60, 70, 80. And we don't know what this is. This is some fictitious substance. But let's say that our question asks, that's really hard to see. A solution of 100 grams holds 25 grams of solute at 25 degrees Celsius. Is the solution saturated? So if we come to 25 degrees, right about there, we come up, we hit it, and we take it over. At 25 degrees, we can hold 25 grams. 25 grams is going to be right about there. So that's unsaturated. We're okay. We're under the curve. So 25 grams is unsaturated. When would this be saturated? This would be saturated at 45 grams. So there's a sample kind of calc. Now, here's another one that, this one was pretty easy. We had 100 grams, but what if we had a different amount? What if we said, hey, by the way, in this one, B, we're going to say a solution holds 100 grams of solute in 250 grams of solution. Is it saturated? Sneak that one in. Well, now if I grab my calculator here, what I have is, I have 100 grams in 250 grams. Well, I need to know what that is in 100 grams to max that out. So wouldn't I just say, so this would be 40 grams and 100 grams. Uh-oh, we need a temperature. We're also going to make this at 25 degrees Celsius. So now we're at the same temperature we were, but now instead of it being 100 grams of solution, it's now 250 grams of solution. Oh, well, I just have to use a ratio, bring that down to 100. Now it's 40 over 100. Remember, we just said 45 grams per 100 was saturated. So this one is okay. This is unsaturated still because we're at 40, not 45. So there's my second kind of problem. You guys know me, usually we do 2 examples, but this one, I wanna just kind of one more, humor me. This is the how much would recrystallize. And so for C, a solution is cooled from 60 degrees Celsius to 20 degrees Celsius. If you had 100 grams of solution, how many grams of solute would crystallize? Okay. So in this case, I gotta go back. We're going from 60 to 20. So 60 degrees. I don't know if this is yellow on yellow. Not bad. At 60 degrees, I've got that much. Okay. Pretty close to 80. Okay. And at 20 degrees, these are my 2 temperatures I was given. The amount that recrystallizes is right there. And that looks to me like it's somewhere between about 38 and 78. And so what we would say is 78 grams per 100 grams minus 38 grams per 100 grams. And this is going to give us about 40 grams. And I'm going to give you even the little squiggly equal sign. 40 grams would crystallize. I got to be realistic. We're reading a graph and we're interpreting numbers from that graph. There's got to be a little leeway. There's got to be a lot of leeway in interpreting these graphs. But basically, I've shown you the 3 kinds of questions that come along. We've defined what solubility was. We made the graph. We interpreted how much at a certain temperature. We interpreted what if it's a different mass of solution that you have. And we did the last type of problem, which is the how much would recrystallize from this solution. So I'm Smath. This should be enough to get you a really strong start on the solubility curve worksheet. As always, if you have any questions, please come see me.